Hello, sir.
Hello. Hello,
Okay.
sorry.
So, Khushbu, please introduce, sir.
A very good evening to all. Welcome to day 4-7 technical session of 6-day online faculty development program on electric vehicles and charging station technology for sustainable development sponsored by AICTE ATAL. Today's resource person for this session is Dr. Shivakumar Nadarajan, sir. On behalf of the organizing team, I welcome you, sir, in our today's technical session. Before we start your expert lecture, sir, I would like to share a short biography of you to the participants. Dr. Shivakumar Nadarajan, sir, is senior member IEEE, received BTech degree in Electrical Electronics Engineering and AMTech degree in Electrical Drives and Control from Pondicherry Engineering College, Pondicherry, India, and the PhD degree in Electrical Engineering from National University of Singapore, Singapore. He has around 20 years of industrial experience from 2009 to 2024. He was the Electrical Capability Group, Applied Technology Group, Rolls-Royce Singapore PT Limited, Singapore as a technical manager, electrical equipment health monitoring. Since July 2024, he has been working as an associate professor in the Department of Electrical Engineering at Singapore Institute of Technology, Singapore. He filed 40 patents in US and Europe, published more than 50 papers in international journals and conferences. His research area interests include condition monitoring, health monitoring, failure prognosis, electrical machine, electrical drives, power electronics, and machine modeling. With this, I would request our expert Dr. Shivakumar Nadarajan, sir, to kindly enlighten us his words of wisdom. Sir, please.
Hi, good evening, everyone. Thanks for joining. Okay, so could one of you confirm whether you can see my screen? Are you able to see my screen?
Yes, sir.
Yeah. Okay.
Yeah.
Okay. Excellent. So yeah, today I'm going to talk about the net zero and electric aircraft. So basically, so net zero is, one of the initiative of the net zero is the electrification. So I would like to talk a bit more about the net zero because I understood that this session, the participants are some of you, or maybe the students, and some of you, maybe faculty, training and coaching the next generation of the workforce to contribute to the society. So the net zero is being a topic. It's not an emerging topic. It's been the hot topic in the last 5 years, and it's been there for quite some time, like around 10 years. But in the last few years, like 5 years, it's been like a key topic in industries and even countries. So I would like to, if you're joining and contributing to the industry, or even if you're joining any government organization, so you should be aware of what net zero means and why it is important. So that's the key focus for the first half of the, at least the 1/3 of the presentation. And then I would like to talk about the aviation industry and its emission, and what are the measures that the aviation industry is taking in order to cut down their emission. So it's kind of, aviation industry is quite big and it's been there for 100 years. So we cannot just take a step measure in order to eradicate the emission. So it has to be the different measures have been there, so without creating any disruption in the aviation. So that's we talk. When I would like to highlight what are the different measures being taken there. And then following that, since this forum is to talk about the electric vehicles, so I want to talk a bit more about how this electrification assists in reducing the CO2 emission in the aviation industry. So that's the focus, and then talk a bit about the electrical machines, power electronics that you've been currently being designed and developed to use in the electric aircraft. And then some of the challenges, because aviation industry, is go with the by loop, basically. So even if you're bringing the new technology, and we still need to get the get it qualified and approved by authorities to fly. So those are some of the challenges. So I just want to highlight some of the challenges that the aviation, the OEMs in the aviation industry is facing in order to certify that products to use it in electric aircraft. Okay, so what does net zero mean? Is that the net zero is basically, it's the net zero is an initiative. It's not an initiative. It is kind of it's a kind of the pledge that the countries is or the global is globally is being accepted to make. The net zero means the emission and the absorption or balance. So it's kind of, whenever I show this slide, I always use some the analogy of kitchen actually. So where we are now is currently is that we are somewhere here, right? If you look at the CO2 emission, the greenhouse gas emission is about 55 gigaton of CO2 equivalent per year. So we are somewhere here. And then if you look at the amount of carbon that being absorbed or removed from the atmosphere through the natural means like the trees or forests that we have, it's very little actually. So the emission is really high, and then the absorption or removal is really low. So this is a big imbalance that we have now. So this is kind of a take analogy like, okay, you have a kitchen, an enclosed kitchen, and we have a small ventilation in the kitchen, like maybe like 10 centimeter dia, the ventilation. And if you're using a kind of a wooden stove to cook your dish, so when you burn the wood, what happens? It releases smoke, right? So the smoke, when it's eventually it's built up, the rate of the smoke being released from the wood may not be maybe much higher than the rate the air is being ventilated through the hole. So eventually over the period, what happened? The kitchen is filled with the more smoke. So that's kind of the situation we are in. So the smoke has been built. CO2 greenhouse gas has been emitted more and more in our environment, in our atmosphere. But the removal is like the small ventilation hole that we have in the kitchen that naturally let the air go out. So that's the kind of the situation we are in. So where we want to be is that we want by middle of this century, that's by 2050, we want to strike a balance. So the amount of now I am removing the kind of the wooden stove in the kitchen. Going back to the kitchen analogy, I'm removing the wooden stove now and replacing with the gas stove, right? Or maybe put them in a gas stove, yes. So that little bit of the CO2. And then if I put a same ventilation that I have in the kitchen now, I'm putting a fan to push the air out. So by doing that, what happened? I may be able to strike a balance. The amount of the smoke that being released by the gas stove, because the gas stove releases lesser smoke than the wooden stove, right? And then since I put a fan on the ventilator now, it can suck the air. So the rate at which the gas stove is generating the smoke, maybe the ventilation fan may be able to remove it quickly. So the air inside the kitchen is not polluted. So that's a sort of balance that we want to make. So basically, we want to move from here to here. That means we want to have the amount of CO2, the greenhouse gas being emitted in the atmosphere should be absorbed by some means, so that we can strike a balance. So that's called net zero. So your emission and absorption or balance. So you are releasing the net CO2, net emission is zero, basically cancelled out. But with the current scenario, like if you are emitting like a 55 gigatons of CO2 equivalent, carbon equivalent, and if we want to remove that completely by some mechanism, it's impossible because the technology currently isn't there to absorb all the greenhouse gas that we emit, like 55 gigatons, right? So what we want to do is we want to actually reduce the CO2 emission from where we are. So we want to gradually reduce the CO2 emission by adapting the new technology or relying more on the renewables. So reduce the CO2 emission, and then at the same time focus on what are the methods that we can use to remove the carbon dioxide from the atmosphere. So that's kind of technology development, focus on technology to reduce the CO2 emission by maybe by going to a completely different fuel or increasing the efficiency of the system. At the same time, also invest and focus on how we can effectively remove the CO2 from the, or accelerate the removal of the CO2 from the atmosphere. That's we might have to focus. So that's the transition we want to achieve in next 15 years in order to meet the CO2, in order to strike the balance between the emission and the removal. Okay, so by doing this, why we are doing this? We want to do this because we want to limit the global warming by 1.5 degrees Celsius. So compared to the pre-industrial era, like 150 years back, and where we are now, the global temperature has already been increased like 1.45. I have a slide to show on that, almost 1.45. If you're not taking any measure, the temperature rise would go higher and higher, and it is like a 2 degree Celsius, gone increased by 2 degree or 2.5 degree. What happened is kind of create a natural catastrophic that may be very harmful to the human race. So that's why the countries globally, the measures have been taken in order to achieve the net zero by 2050, so that we can contain the increase in the global warming by 1.5 degrees Celsius, so that we can prevent any natural disasters that in coming years. Okay, so I mean, when it was the kind of the net zero, the pledge has been taken in the Paris Agreement, which is, let's term it as a Paris Agreement. It's actually it is agreement that happened in a conference organized by the United Nations Framework Convention on Climate Change, which happened in 2015 in Paris. So that's why it is, in short, they call it as a Paris Agreement. So it's this is the kind of different countries and organizations that they have came together to committed to address the climate change collaboratively. And so this is the aim is to by like I mentioned, by second half of the century, we want to balance between the emission and the removal from the atmosphere, the greenhouse gas emission and removal. So we want to strike the balance there. So the primary goal is to limit the global warming by 2 degrees Celsius, but 2 degrees Celsius is still harmful to the globe. So everybody is trying to focus on the stretched target, which is contain the increase in the global temperature, the global warming by to 1.5 degrees Celsius. So that's a target. So by in 2016 we were here, like we were emitted like 52 gigatons equivalent of carbon dioxide. But here, I mean, in 2030, if we don't take any measure, we'll be emitting like 50 to 58 gigatons equivalent of CO2. But if you look at the current statistic, we already emitting like 55 gigatons of CO2 emission. So by 2030, if you don't take any measure, it will be even higher. So this is, but our target is we have to reduce this the CO2 emission. If you want to achieve the net zero by mid of the century, we have to reduce the CO2 emission at least half. From 52, we have to bring it to 25 in next 5 years. I mean, that's really the hard target, but we are focusing on this because this is the kind of it's not the I mean. I said that it is a hot topic. The reason being is that I worked in industry for 20 years. In the last 5 years, I have seen how the industries are transforming their products and then transforming their vision and strategy, their roadmap in order to adapt this the net zero. The reason is that there are many reasons. The key few reasons are that the company always want to sustain in the market. If you want to be sustainable, they have to make their product sustainable. So if they don't take any measure for their product, I mean, reducing the emission from their product or reducing the emission from their manufacturing facilities, they may not exist in long run. So they said that's one of the reasons that they want to seriously taking into it and that they want to adapt it. So if you look at any big organization, and if you go to the website, on one page, you can see that what are the measures they're taking for net zero. And the second reason is, the first reason I mentioned is to be more sustainable in the market. The second is investment. If you look at any big companies, and if you look at the parameters in order to assess the company value, there's one parameter called ESG, environmental, social, governance. So that factor is being calculated. I mean, one of the consideration to calculate the factor is that what initiative that this company is taking for the environment. So if if a company is not taking any initiative to achieve this net zero target, the score on the ESG is lower. If the score is lower, if the company is categorized as something like it's not investment grade company, so the investors are not investing those companies. They just try to stay away from those companies. So in order to attract more investment, companies are trying to increase the ESG score. So so they are looking at how they can contribute to the net zero target. So these are the reason. I mean, the other reason is one of the survey that conducted upon the millennials, I think in UK or somewhere. The millennials or the kind of the next generation workforce, they are ready to take the. I mean, they are the one going to contribute contribute to the society. So they say that if a company is not taking any measure on the removal of CO2 or not taking care of the environment, they're not interested to work for the companies. So that's it's alarming for industries and companies, because they see that, okay, if the new workforce are not ready to join that because they're not taking care of the environment, and it may be like, again, they see the downfall. So that's the other reason that they want to give more focus on the net zero. So these are some of the main key reasons, and there are many other reasons as well. So if you go and browse any companies that you're interested or want to pursue a career, you go and read what are the net zero goals, and you can see that there may be electrification. So these are some of the things it will be you should be aware of and know before you pursue career in any industry or any company. Okay, so that's kind of brief background about why the CO2, I mean, the net zero and the CO2 emission removal are important. You may be wondering, okay, the previous slide I was showing, we have to strike a balance. So we have to invest, on focus on how we can remove the CO2. So natural process of removing CO2 is it's happened through the forest, right? The trees that take the CO2, so they absorb some CO2. But how we can accelerate that? So these are some of the options for greenhouse gas removal. The one is the afforestation. So wherever we don't have a forest, we can create a forest to create more area for the carbon, the CO2 absorption, greenhouse removal. And then the other thing is built with biomass. So it's kind of going back to the tradition. In the olden days, they use the wooden materials to build house. So using the organic material to use in the buildings. That will, again, we are basically putting the carbon on the building, and we are not releasing to the atmosphere. And then once the building is demolished, again, it's going to the earth. So it's not that you're taking the carbon and using the carbon, keeping it in the building itself. It's not that being emitted to the atmosphere. That's one way. And another one is the biochar. Biochar is something like we burn the organic material like wood or whatever the organic material at a very low oxygen, so that we create it as the biochar. The biochar is used to fertilize the land, or used as a catalyst, or used in filters. So it has many purposes. So by doing this, by converting the organic material to biochar, we are also reducing the CO2. So that can be a way of reducing the CO2 or removing. I mean, instead of burning something and releasing the CO2, we are just stopping that happen. So that's kind of considered as a removal process. And the carbon direct air capture, it's a big topic again. There's many industries or companies that are emerging now in order to increase the direct air capture. Direct air capture is they put big fans to suck the air in the atmosphere, and then they have a filter which filter out the carbon, and then they have some solvent to dissolve the captured carbon. And this captured carbon either store, and when they stay stored, it is kind of stored inside. We drill a long hole, and then we pump the petroleum to create a different fuel. Right now, this is a reverse process. They capture the carbon, and again they pump it inside the earth and store it there. So that's one way. Other way is this one, bioenergy with carbon capture and storage. That is something like, okay, capture the carbon, use to capture carbon, and bring the hydrogen molecules from the electrolysis of the water, and combine the hydrogen and captured carbon to create a hydrocarbon chain. Let's say again the synthetic fuel, and then you can use it again. So that is the another process. And there are many other processes like enhancing weathering, like the silicate and carbonate that can absorb the CO2 from the atmosphere. So that's kind of natural process, slow process, how we can accelerate the natural process of the carbonate and silicon that absorb the CO2. So these are different methods, options that have been available to remove the CO2, and industries are being looking into these things to see how we can use this in order to, accelerate the carbon removal. So this is the annual temperature anomaly. That's how it's been increased. You can see that, industrial revolution started somewhere in middle of 18th century. And then over the period, you can see that the temperature has been increased. The global temperature has increased by 1 degree somewhere in 2000, and then it's been quickly increased to around 1.45 recently. In 2023, it is 1.45 degrees Celsius. If you're not taking any measure, we can just curve is that the slope is quite high, so it may increase quickly. So that's the reason that we are talking about this topic. Okay, so I explained why it is important and what was the net zero target, and now let's see whether we know. Okay, it's important to achieving net zero target, or the countries are serious about it. Yes, as of 2024, July 2024, so far the 107 countries, they are responsible for emitting the about 82% of the global greenhouse gas emission. So countries which contributing about 82% of the global CO2 emission, they already have pledged to adapt the CO2 net zero initiatives. So there's not that, the countries, you can see that there are many countries that's already, they implement the policies, the laws to achieve this net zero target. And some of the countries, our neighboring countries like Bhutan, they claim that they already net zero on some of the, they look at the domestic sector. They already implemented the policy documents to use only net zero fuel for the domestic purpose. By doing that, they say that they already achieved a net zero. And Singapore, you can see from all the sector except the international aviation shipping, they want to go 100% net zero by second half of this century. So they already have a policy documents in place. So this is kind of the government imposing the policies to ensure that the new vehicles or new means of generating electricity or the new means of operating the equipment in the industries to ensure that the emissions should be reduced. So that's the kind of country itself implementing laws and policies to achieve that, which is good. So almost 80%, almost all the countries who contribute to CO2 has been taken it seriously and implementing the policies, which is good. And to measure the progress, whether we are able to achieve the net zero by 2050. So they have, they come up with the 42 indicators to track the progress with the target of track the progress of the 2023, 2030, and 2050. So these are the 42 indicators that have been used to assess whether at what direction the globe is going to achieve the net zero target by 2050. And if you look at these indicators, it says that out of the 42 indicators, only one indicator is on right direction or right track, which is the sale of electric vehicles. But whereas the other indicators, like some of them are in the right direction, but way behind the schedule or off track, and some of them in the right direction, but very well off track. It's very slow in achieving meeting the milestones, basically. And some of them are taking the U-turn. It's going the wrong direction. For example, like carbon intensity of global steel production. So global steel production supposed to reduce because the carbon to make the steel, a lot of energy being used, and most of them comes from the fuel, the fossil fuels. So the milestone says that the global steel production must reduce the CO2 emission by this much, but actually it is increasing. Increasing the CO2 emission when compared to the 2015. So that's why it says it is going wrong direction. So likewise, it's not it's sometimes the economical factors also drive this. So it's not that it's too hard to say there's it's who is right, who is wrong actually. So yeah, this is the status now. So only one track for the 42, only one milestone is on track, and the rest of them are either off track or going in wrong direction. Some of them going in wrong direction. So this is the status. So next 15 years is very crucial to bring everything on track, and then and if we bring on track, then only the net zero is achievable by middle of this century. Okay, now let's look at the aviation industry emission. So what is the chart that you're seeing here is last year, not last year, in 2023, it was recorded that the global CO2 emission is 57.1 gigaton equivalent of CO2. So this is the status. It's really high side. And out of which we see that the 26% is from the power industry, and then the transportation industry is 15%, and other industries like 11, and so on. You can see. So out of the 15%, the emission from the transportation industry, the 2% is from the aviation. So it may see that, okay, 2% from aviation doesn't look really high, but if you look at the way the aviation industry is growing, the statistics says that the aviation industry air traffic conversion will increase an average of 4.3% per annum. So it will be kind of, if with this rate, it maybe get doubled in another 15 years, probably. So the emission would be, the rate it is growing is really high, so emission will be higher as well. So it's important to look at how we can reduce what measures we can take in order to reduce the emissions from the aviation industry to contribute to achieve the CO2, achieve the net zero initiative. Okay, and also it's estimated that about 10 billion passengers a year will be carried by air by 2050. So just really significant number here. Okay, so it's clear that aviation industry is contributing 2% of the global CO2 emission, and then it is going to increase. The growth of the aviation industry is significant. So if you don't take any measure, the aviation industry emission will be keep increasing. So it is important to take measure. Okay, so just before to look at what are the measures that aviation industry has been taking last few years, but let's look at how this aviation industry has been categorized, the market segment. The aviation industry has been the market segment of the aviation industry is being categorized like UAM, commuter, regional, medium haul, and long haul flight. It's based on the size of the aircraft and the passenger that it carries. Okay, so the market, they use the market segment to classify because the market is different for these things. So that's the reason, and then that's one of the factor. And then the players, the players in the sense that the airlines, or the industry which serve the OEMs which serving the parts for these, it's also being categorized according to this. So that's why they use the market segment to categorize the aviation industry. So these are the 5 categories. It's not a fixed, like some use the 4 categories of the segment, some use 5. So here I've taken on with the 5 segment. So eVTOL and air taxi is being a kind of a emerging market now, whereas these have all been there for quite some time. So now let's see what initiative has been taken in order to achieve this net zero initiative or target by the UAM and commuter, regional, and medium and long haul flights. Okay, so in order to achieve this net zero, these are the measures, like these are the levers, basically. The innovation with technology. That means that adapt the technology, the emerging technology, to change the way the industry is being operated, or the technology is being used in the aircrafts in order to increase the efficiency, or basically the focus is kind of improving the fuel efficiency, and also adapting the different the source of generating the thrust for the aircraft, so that we can, the way of generating the thrust with the lesser or no CO2 emission. So these are the kind of technologies being looked into here to reduce the emission. And the other thing is improvements in operations and infrastructure. So which means that it's operational focus. It's something like if the aircraft is flying with lesser passenger, it's not generating revenue, and so it's kind of if you're not, it's not being utilized fully. If you're not utilized fully, it's kind of the CO2 emission per passenger is higher. So one of the focus is here that how we can improve the scheduling of the aircraft so that the flights are being full, or the improvement in the utilization, so that will reduce to the fuel burn per passenger. So here the other initiative is something like all the airlines are coming together, kind of they work together in order to share the passengers, share the aircraft. So in order to increase the utilization of their infrastructure. And then sustainable aviation fuel, it's another big topic, because if you look at the long haul flight, we can't electrify them 100%. So we have to do something with the fuel, so that the fuel can emit less the CO2. So this sustainable aviation fuel, the fuel is something, that's a big topic by itself. So there are various fuel option has been covered here in order to achieve the net zero, like using the feedstock like biomass, like palm oil to create the fuel. Because if you get the fuel from the plants, it's kind of plant absorbs the CO2 and then gives you're using that as a fuel and emitting the CO2 again into the atmosphere, and again the plant absorbs that. So it's kind of the cycle, the carbon neutral cycle is there. So that's one way of using the biomass. Other thing is using the electrolysis approach, like Fischer-Tropsch approach. Like I mentioned, use the carbon capture, use the fans to capture the carbon from the atmosphere, then use the renewable electricity to break down the water into hydrogen and oxygen molecules, and combine the hydrogen and carbon to make the hydrocarbon chain to create a synthetic fuel. So that's other method. So there are many methods that comes under the SAF. So yeah, that's a big topic by itself. It's not the it's not the, I will talk about this a bit later as well. And out of scope carbon reduction market. This is again I was mentioning. So kind of carbon credit sort of thing. So whether the airlines can invest in the carbon capture or direct air capture technology to increase the efficiency of, they contribute to the carbon capture. So that the amount of carbon that they emit, and they invest some technology to capture the carbon back and putting it in the air, or using the carbon to do something useful. So that kind of helps to neutralize the carbon. So this is the kind of it's a passive approach, whereas these are all kind of active approach of reducing the CO2 emission. So now let's look at the in more detail. I mean, I was talking about the first approach is innovation, innovating with technology. So what are the innovation has been looked at? If you look at aircraft, the fuel consumption of aircraft is based on its weight. So by reducing the weight of the aircraft, you can, so if you reduce the weight of the aircraft, you need less fuel to fly the aircraft. So you're basically increasing the fuel efficiency. So the industry is looking at like composite materials to make the aircraft, the body is lightweight. So by making the body lighter, well, we need less fuel to fly. So just kind of increase the fuel efficiency. And then electrification. So this plays a significant role. Because the aircraft, there's hydraulic and pneumatic systems are widely being used. So hydraulic and pneumatic system adds weight to the aircraft. So by replacing this hydraulic and pneumatic system with the electrical system, we would be able to save the weight and space in the aircraft. So if we save space, we can accommodate more passengers, right? So these are some of the measures, and also the next generation engine. So the engine manufacturers like Rolls-Royce, GE, Pratt & Whitney, they're investing a lot of money on how they can improve the efficiency of the engine. So for example, if they increase the efficiency of the engine by 1%, which will create a savings of like millions of dollars for airlines or per year per aircraft potentially. So that leads to the kind of significant savings on the fuel burn. If the lesser fuel burn, it's not only the benefit to the airlines, like because they save the money on the fuel, but also it's good for the environment, because if you burn less fuel, the less CO2 being emitted. So this was estimated that the 30% improvement in efficiency by 2030 compared to 2005 can be achieved by adapting these different measures, like going with lightweight material, and then a system electrification and next generation engine and so on. And it's predicted that 42% reduction in global aviation emission through this technology. So efficiency increased by 30%, and then emission can be reduced by 42%. Okay, so some of the example for the electrification is currently, I think maybe I can talk about that in the later slides. Yeah, I'll talk about that one here. Okay. Okay, so next let's look at, okay, so these are some of the initiatives being taken to increase the efficiency of the aircraft, basically. So there include the material research, electrification, and then the next generation engines, right? So now, as we are most of our electrical engineer, let's see how the electrical technology is contributing in achieving the net zero in aviation. So if you don't take any measures, and then you can see that the aviation emission would be like the 2 gigatons equivalent of CO2 by 2050. And then, I mean, actually supposed to be like 2.8 tons of emission. But the natural continuous fuel efficiency improvement that is made by the aircraft design or the novel engine, it could be like, it can save some 26%. So we may be able to reduce the emission by 26%, and it stands about 2 gigatons equivalent of CO2. But still, it's really significant. We cannot have some kind of carbon capture technology to absorb this much of CO2. So we have to reduce. So what are the measures that are being taken, potentially taken by to achieve this by the net zero by 2050? So you can see the different color coding, the additional fuel improvement, that 13% that comes from the lightweight material or the novel engine concept or the aircraft design, along with the 20% over there. So overall, they say that this kind of 33% can be achieved by the engine fuel efficiency or the material or some other means. Okay, but you can see the red color. This is a battery electric. It's kind of using the battery technology to propel the aircraft, which will reduce the emission by 2%. Another 26% is to the hydrogen. The hydrogen is, it could be the hydrogen used as a fuel, or it could be the hydrogen use the hydrogen as a fuel source. Okay. And then another 29% you can see is power to liquid. Power to liquid is a synthetic fuel, which, like what I mentioned, capture the carbon from the atmosphere, and then use electrolysis to break down the water molecules, and then combine the hydrogen and the captured carbon to make the synthetic fuel. So that is that's called the power to liquid fuel. That's a kind of 29%. So if you look at this, whether it is a hydrogen fuel, if it is coming from the fuel cell, then again they're going with the electrical propulsion. So electrical engineer has to design and develop the electrical propulsion system. Even if they use the conventional engine and they still use the hydrogen fuel, again the hydrogen fuel creating the hydrogen fuel needs a lot of energy. So again for the power to liquid, also in order to break down, do the electrolysis and the Fischer-Tropsch to combine the hydrogen and carbon molecules to create a synthetic fuel, again need a lot of electricity. So without if they use a conventional fuel, the fossil fuel to generate electricity, it's impossible to meet the net zero. So the electricity being used, or power used to generate the hydrogen or generate the synthetic fuel, which is a power to liquid, is possible only if they go for the renewable. So if they go for renewable, use the renewable electricity, renewable energy to generate the hydrogen or power to liquid, then only they can achieve this the carbon saving or reduction in carbon CO2 emission. So as electrical engineer, we have a big role to play here. So we have to either contribute directly on replacing the conventional the combustion engines with the electrical propulsion for the battery or fuel cell aircraft, or increasing the efficiency of the existing aircraft by adapting more electric technologies. I will talk about that later, more electric technologies by replacing some of the existing system like a hydraulic and pneumatic, or you have to make a significant contribution in order to increase the production of the renewable power. So then only it's all possible. So the electrical engineering going to play significant role or crucial role to unlock the 55% of global greenhouse emission reduction in the aviation industry by 2050. So this electrical engineering is going to play a crucial role. Now let's look at, okay, how this electrification journey in the aviation industry. So the commuter and the air taxi, it's kind of going to use either the full electric using the battery or the hydrogen fuel. So that's will be happening from, you can see that the air taxi or small commuter aircraft with the 9 to 19-seater aircraft, which will be fully electric. Which use the battery or hydrogen fuel cell. So you can see this flying from this year onwards. The regional aircraft, which are slightly bigger in size, where it may be possible to use the hybrid electric and fuel cell to fly them. It may be happening from 2030 onwards. And then the short haul, medium haul, and the long haul aircraft, where they need to rely on the sustainable aviation fuel and hydrogen. So here the electrification helps a little bit, but not significantly. We have to rely on the sustainable aviation fuel or hydrogen as a fuel to achieve that. Whereas for the commuter and regional, electrical propulsion is going to play a significant role to reduce the carbon emission. Okay, so aircraft electrification. So how the electrical technology or electrical engineering going to assist in achieving this the emissions, reducing the emissions in all these the market segment of the aviation industry. Okay, so more electric aircraft, if we take it, the more electric aircraft is this concept is for the long haul or medium haul, mainly for the long haul and medium haul aircraft, which is a bigger aircraft that flies from one continent to another continent. So these aircrafts are huge, and it uses it's difficult to completely change them to the full electric or hybrid electric. So here what we can do is we can kind of replacing some of the hydraulic and pneumatic system with the electrical. Like for example, in the gas turbine engine, there are the many stator vanes in the compressor and turbine blades, turbine. So the angle of impact for those the blades need to be adjusted. For that, they use the hydraulic actuators. Well, we can replace this kind of many initiatives going and in the industries to replace that with electric. And the other approach is to start the aircraft. I think I have the slide here. Maybe I can move to that this slide. Yeah, more electric aircraft. If you look at any conventional aircraft, that's the wide body aircraft, which used for long range or medium range aircraft. They use the hydraulic system. So you can see that the red color thing is a hydraulic system that runs from the wings to the body of the aircraft and tail and so on. So this is used to control the flight basically. Even if you in the aircraft, you can see that on the wing we have the various actuators to adjust the wing, the flap of the wing. So for that they use the hydraulic actuators to lift and down. So these hydraulic actuators, I mean, because if you use the hydraulic system, you need to carry the hydraulic, the fluid along with that, and a lot of tubes running here and there, and it's heavy. So by replacing this with the electric motors to actuate the wings, we can save the space and you can save the weight. Similarly, and also for the and also the hydraulic being used to control the engine as well, as I mentioned. And the pneumatic is the blue color thing that runs. Is also pneumatic. The pneumatic is used to start the engine basically. So in the electric vehicles, like electric car, we have a starter engine. Sorry, not the electric car. In the conventional the cars with the combustion engine based car, we have to start the combustion engine. We have the electric starter. So by pressing when you press the start button, the electric starter starts to start the engine. But in aircraft, the gas turbine engines used in aircraft, they use the pneumatic power. That is they have small engine in the tail of the aircraft. That's called the APU, auxiliary power unit. That small engine starts first, and then that pump the air from the tail of the aircraft all the way to the wing, and then we push the pressurized air to the fan blades, the main engine fan blades. So then the fan blade rotates, and then the engine starts. So it's a kind of very inefficient process because we use a small engine to generate the air, and then that air has been pushed to all the way from the tail of the aircraft to the middle of the aircraft, and then push it to the engines to start the gas turbine engines, right? So it's very efficient. Instead of that, we can put a motor to start the engine, like what we do in the IC engines in the car. So that's also that's a kind of so these are the initiative to increase the efficiency of the existing aircraft so that we can reduce the CO2 emission. Then the other example is like, again, pneumatic is used for the de-icing. De-icing is during the winter, if the ice are deposited on the windscreen or on the wings, it's kind of, we have to de-ice and remove them first before takeoff. So for that, again, they use the hot air from the small engine and tail of the aircraft to do that. So again, it's very inefficient process. So instead of this, we can replace that with the electric heaters, right, to do that. And also for air conditioning inside the aircraft, a small amount of air that been sucked by the main engine is bleeded to the aircraft chamber to maintain the temperature, or condition preventing the pressure inside the aircraft, which is again, it's if you breathe a little bit of air from the main engine to the cabinet, you're basically losing the efficiency of the engine. So if you use the electric air conditioning system, we can remove this part. So that will also contribute to the increasing the efficiency of the engine. So these are the different I mean, these are potential options to replace some of the existing pneumatic and hydraulic systems in the aircraft with the electric. By doing that, we can reduce the weight, which also contribute to the fuel efficiency. And the electrical systems has better efficiency than the hydraulic and pneumatic system, so which is also contribute to the efficiency. So this is the focus for the bigger aircraft. So and this is all titled as a more electric aircraft rather than the full electric aircraft. Okay. So the second initiative is the hybrid electric aircraft. The hybrid system is again it's a combination of the advantages, combine the advantages of the combustion and electric engines, right? So this is something that you all very well know. Okay, so hydraulic, the hybrid electric propulsion leads to the better energy management, reducing the fuel consumption up to the 5% compared to the standard flights. And for the other flights like a helicopter or the propeller-based the flights, which doesn't have the fixed wings, the efficiency could be even higher. And then again, two categories of the hybrid system: serial hybrid and parallel hybrid. Serial hybrid, the motors are used for the propulsion, and the engine is used for the generating electricity, and the motor is powered by the electricity generated by the engine as well as the battery. Parallel hybrid, the combustion engine is the primary source of power, whereas and the electrical motor is used to assist the provide additional torque to the combustion engine to generate the more thrust to fly. Okay, so that's the hybrid option, and these are some of the demonstrators. So in order to achieve the hybrid, conventionally, if you look at the aircraft, the body comes from the airframer. Some of the key players in the airframer industry is Airbus and Boeing. And the engine comes from the OEMs like Rolls-Royce or General Electric or Pratt & Whitney, Bombardier, and so on. But if you want to adapt the hybrid, we need motor, we need the generator, we need power converter, we need battery, right? So again, so we need the OEM. OEM is the original equipment manufacturer, right? So to contribute to this change to bring more the electric components to the aircraft. So the companies like Airbus, Rolls-Royce, and the Siemens, they all come together in order to build this demonstrator and demonstrator. So basically, in this demonstrator, Siemens provided the motor and the power converters for the propulsion, and then Rolls-Royce provided Rolls-Royce is good in designing the engine, so they provided the small engine, gas turbine engine, which is primarily to generate the electricity. So that drives the 2 megawatt generator to generate the electricity, and also they provide the power converter. And then the Airbus provided the cockpit HMI and the control system, battery, and so on. So they came together, and then they performed this demonstrator 2 years back to demonstrate the concept of the hybrid electric aircraft, basically to understand what are the technical gaps that exist if you want to realize this hybrid electric propulsion for the regional and long-haul flights. And then, okay, third category of the focus is the, let me go back to the slide. Yeah, so I talk about the more electric aircraft, how we can electrification helps on the reducing the, increase the efficiency and reducing the CO2 emission. Hybrid electric, I talk about that what are the companies that are coming together and demonstrating the concept so that it will again contribute to the 5 to 10% savings in the fuel savings. And then full electric aircraft, that's what we're going to talk about. The full electric aircraft is mainly for the urban air mobility industry, which is the for the air taxi, which flies about a 40 kilometer to 100 kilometer range, 35 to 100 kilometer range. Okay, so with the passenger number of 6 to 10 or 12 passengers, so that is the urban air mobility market. Because with the existing technology, we are able to only completely 100% electrify these aircraft, not the regional aircraft which where the 90 or 100 passengers travel, or not the long-haul aircraft where the 200 or 300 passengers travel. Okay, so with that current existing battery technology, with mainly primarily the battery technology, we would be able to only fully electrify the small aircrafts. Okay, so why? I mean, this is again a big topic. The urban air mobility is the emerging topic, and it's been a spotlight for the last 5 years. The reason is that the United Nations predicted that by 2050, in 15 years, 2/3 of the world population will live in cities. So you can imagine that now itself, the cities are really crowded, and during the peak hour, if you're using the land transport, it's really crowded and traffic and congested. So the infrastructures are really stretched. So if you want to, imagine that in 15 years, more and more people are migrating to the city, and the city is really going to get crowded. So the land transportation is already stretched. So the alternate, so we have to look at the alternate option. The alternate option is the air taxi. So there's belief that okay, this air taxi market going to boom in next 15 years. So that's why companies are, I mean, many companies, many startups are looking to develop the electric taxis or air taxis for the urban air mobility. Okay, so basically, if you look at the full electric aircraft, the three key components are the electrical motor, converter, and battery. So if you look at the electrical machines are in general like can achieve more than 95% efficiency, compared to the combustion engine, which is efficiency of around 50% or below. So definitely the electrical motors are efficient, but when it comes to the aerospace application, aerospace application always has a constraint. The two key constraints, one is the weight and the other one is the space. Okay, so weight constraint, how we can reduce the weight of the electrical machine. So that's a primary focus on selecting or building the electrical machine for the aerospace application. So currently, the state-of-the-art motor can provide the power density of 8 to 10 kilowatt per kilogram. Okay, but if you want to use the electrical motors for the aerospace application, the power density should be in the range of more than 13 kilowatt per kilogram. So that is like 30 to 50% improvement in the power density is required. So the industries, as well as the main OEM, the original equipment manufacturers, are looking at the various options of increasing the efficiency and power density of the machine, the motor. So like increasing the power of the magnet. They're looking at the technology like increasing the power of the magnet, reducing the weight of the rotor and stator by using the new materials like carbon fiber, and also they look at the other options like the machine topology itself, like radial flux machine is what widely used. Can we go with the other options like axial flux machine and transverse flux machine? The axial flux machines has various advantages, like it is the conventional machine you have a fixed stator and fixed rotor, but whereas in the axial flux machine, if you want more power, we can stack the rotor and stator stages, right? So that is to kind of provide the modularity. So if you want to increase the power, and you can do it by stacking the return rotors, adding the return rotors. So and also it is kind of, I mean, it also reduce the weight of the machine, because usually the OEMs, like original equipment manufacturer, they go for the standard size. The aircraft size, they may have a n number of variants of the aircraft from the different aircraft manufacturers. But the motor manufacturer, they have only selected combinations of the configurations, selected configurations of the machine and the power. So if you want to serve the customer with the multiple requirements, different requirements, so then they can stack them. The modularity helps them to kind of sell the same product for the different specifications and different customers. So the axial flux machine is one of the win in that space. So axial flux machine has been currently been designed and developed, and some of the manufacturers already claim that they have the product which is suitable for the aerospace application. And then the other configuration is a transfer flux machine. If you look at the axial flux machine, the fluxes are in axial direction. The radial flux machine, the conventional machine, widely used machine, the fluxes going in the radial direction. But the transfer flux machine is a provide the flux, it's a combination of the radial and the axial. So which is kind of provide the three-dimensional magnetic field. The advantage of this that the rotor, the windings can be exposed actually in this machine configuration. It's no need to be inside the stator slots. If it is exposed, it is easy to cool basically. So because when it comes to the power density, right, calculation, they also look at consider the cooling. For example, you have a very high power dense electrical machine, but if you say that okay, this machine is liquid cooled, then the power density calculations count the machine weight as well as the coolant weight, cooling pipe, and cooling system weight, everything they put together. So even if you develop the high power dense machine, but when you include the other accessories or the cooling system weight, the power density is reduced. So if you use an air-cooled machine, the power density can be maintained, can be increased. So that's the advantage of the transfer flux machine. So this is the transfer flux machine currently being designed and developed by Rolls-Royce. So for the urban air mobility market, you can see that how the flux has been kind of going three-dimensional. So this is a prototype which they have. This is how the commercial product would look like. So they already built the first prototype, and they're currently doing the testing. Okay, and then the axial flux machine. This is the Magnix is one of the OEM. They developed the propulsion motor, which is using the axial flux topology. So they have machine for the 560 kilowatt machine. And then the power converter is another key building block in the more electric aircraft, full electric aircraft. Again, when it comes to the power density, again, aircraft, the power converter, it's again for aerospace application, the power density is important. Generally, the power converters are quite power dense, but the power converters are the weak link in an electrical drives. Okay, so because when they have an electrical machine, even if the electrical machine can operate for some time, right? But whereas power converter, if it fails, if one device fails, the power converter become imbalanced and may not be useful, right? So especially in the aerospace application, which is considered the safety and mission critical. So which means that if an aircraft leaves port A or airport A, it has to safely land on the port B. If anything goes wrong, anything failed in this mission of going from A to B, it could be catastrophic, and it could jeopardize the safety of the crew and passengers there. So it has to be reliable. So that's why if you look at this configuration, like they have one mission with the multiple winding. This kind of most of the companies are adapting this concept, like they call it as a multi-lane concept. They have a one electrical machine, which is not the simple three-phase electrical machine. The machine would have a six-phase, or some cases it may have a 12-phase missions. And each three-phase of the machine is powered by converter. For example, here it is a 12-phase machine, and they use the 4 converters to power. So even if one converter fails, the other 3 can still operate the propeller to safely land the aircraft. So the safety is the focus here, and also the cosmic radiation that harm the semiconductors and the power converters. That's also the concern. So now the silicon carbide is commonly used for various reasons. One is that the silicon carbide can be switched at a high frequency. So in electrical, if anything is high frequency, the size could be reduced, right? So by switching at a high frequency, we can reduce the size of the passive filters. So the power converter size could be reduced. So that's one advantage of using SiC. And the SiC is a kind of wide band gap device. So even if there is cosmic radiations, when it fly higher in the atmosphere, that come from the sun or some other means. So these cosmic radiations will not damage the silicon carbide device. I mean, most likely that's a kind of it's a kind of it's not assumption. It's theoretically it would create less harm to the silicon carbide device because of it has the wider band gap compared to the silicon device. So that's the other reason for using the silicon carbide in the aerospace application. Okay, so then, so these are some of the power converter prototype which Rolls-Royce designed and developed. You can see the switching frequency, the fundamental frequency is 2.5 kilohertz, and it operates at the 99% efficiency. It can be air cooled or liquid cooled based on the application. Sorry, the images, I mean, I couldn't get a high resolution image from the website. Maybe you can go and read by yourself from the Rolls-Royce website. So these are some of the development happened on the power converter side. On the battery side, so battery is a big hurdle for the urban air mobility, actually. Many companies have started, and 5 years back, many companies has started with the big ambition of developing the aircraft for the urban air mobility. But I think at least half of them they slowed down their research because they realized that the battery technology is not there now to commercialize this urban air mobility. I mean, aircraft, the air taxis for with the current battery technology. With the current battery technology, which provide a power density of 250 kilowatt hour per kilogram. So with this, they can power the small, the 4 or 6 seater aircraft. But if you want to power the slightly bigger aircraft, the power density is not there in the battery. So the companies are waiting for the next generation of battery or new next evolution to take place in order to, with the battery technology, provide the significant power density and safety to realize this urban air mobility, the aircraft for the urban air mobility market. Because the power density is one thing, and also the degradation that happens in the power converter is also higher. Because in order to, as I mentioned, the aircraft comes with this constraint, right? Weight constraint. So to keep the weight lesser, the aircraft, the full electric aircrafts are designed with a less battery capacity. And then for takeoff and landing, they are drawing the power from the battery. The propellers are drawing the power from the battery at a very high C rating, like 6 or 7 times the rating of the battery. So 6C or 7C are being used. So when they set more power, like they discharge the battery at this high discharging rate, like I mentioned, like 5 times the capacity of the battery. The battery, and it's happening at every takeoff and landing. And also again, when they charge the battery quickly, they have to again charge it at the high C rate. So this charging and discharging at a high C rate, it's also bringing the battery life to shorten the battery life. So the more and more replacement are required in the very short duration. So when the calculations are done, it looks like they found that the full electric aircraft technology may be expensive to fly for the passengers. So maybe they prefer to go with the conventional approach. So the industry is mainly waiting for the next battery technologies to move ahead. So that's kind of the impression or that I have based on what happening around in the full electric aircraft development. Okay, so now let's talk about the charging. So the electric aircraft, I mean, we know that airport is for the normal aircraft that we take, right? For the full electric aircraft, they call it as a vertiport. That's a term they use. Vertiport is for the full electric aircraft, which is something like this. You can see that it'll be on there's a car park, the building car park, and it's slightly smaller than or same size of the building car park. And it will have the landing and takeoff, and there'll be maybe slightly bigger if it is a bigger. Some vertiports are bigger where they can charge the aircraft as well, the electric aircraft. So again, to charge the electric aircraft, there have been there are many companies like Skyport is one of the companies who's setting up this vertiport in United Arab as well as in Singapore to fly these full electric aircraft. Say they take the electricity from the grid to charge the electric aircraft, or again, it's kind of a renewable integration, which I take the electricity from the solar or wind to charge the batteries on board the vertiport, and then use the battery to the storage to charge the aircraft. So that's kind of the different options they are adapting or exploring in order to charge the electric aircraft. Okay, so this is my last slide. I think I can finish it in 5 minutes, and then we can have 10 minutes for Q&A. So I talk about the full electric aircraft, and then what's happening on the electrical machine technology, power converter, battery, and the vertiport. Now let's look at, because without the aviation, so without the approval, the electric aircraft cannot be commercialized, because there are many authorities, aviation authorities up there. The local aviation authorities, for example, if you want to fly the aircraft within the India or within a state in an India, there are the local aviation authorities. They can provide approval and they can fly the demo flight or the full electric aircraft. But if you want to commercialize for the global use, there are two aviation authorities. One is the Federal Aviation Administration, FAA, and EASA. So these are the two authorities or agencies. They provide the guideline and standards for design and developing the aircraft. Currently, these authorities, they have the standards and guideline for developing the components for the existing aircraft, like wide body aircraft or the commuter aircraft, which is powered by the engines, basically. But for the electric aircraft, they are currently implementing the standards for coming up with the guidelines. So which is good news, because when this market is being picked up sometime in 2015 or 2016, there was the FAA or EASA are not looking at the standards for the full electric aircraft. So, but now from 2017 onwards, they started looking at it, drafting the standards and guidelines for the non-traditional aircraft, which is the full electric aircraft, which is a good news. But still, it's not easy to certify an aircraft, because the authorities, maybe we can come up with a very wonderful design to increase the power density of the electrical machines or the power converter, but when bringing for the qualification or certification, we have to comply to the many. I mean, the guidelines is quite wider, and then based on the safety of the, if the equipment is safety critical, there's a guideline need to be followed. So if you consider all these guidelines, need to make more and more changes on the product. So at the end, we may not be able to, the design that we propose to increase the power density may not be feasible at the end. So usually how it happens is in the aviation industry is that even before the product has been designed, the design, the development process, the product development process will be brought to the authorities to get the approval for the development process, the design and development process. So the authority says that, okay, you have to go and tell them, okay, this is the process I'm going to follow. These are the steps I'm going to have in order to check my design is robust and rugged. This is how I'm going to write my software. This is the tool I'm going to use. This is these are the process I'm going to follow in order to verify each and every line of my code. This is a method I've taken to evaluate and see that the assurance level, the safety assurance level of the component. So these are the things we have to show it to the authorities upfront before we design and develop the prototype. So then then only we move ahead. So these are the kind of challenges. It's kind of I mean, it is really rugged change. It is something is important when it comes to the aviation industry in order to make sure that it is safe to fly. But again, it is kind of putting a lot of, I mean, it's slowed down the progress. So that's kind of the issues that, I mean, it's not the issue. It's a happy issue to be solved. But it's slowing down the progress. That's what I'm trying to highlight. And the power density of electrical equipment and the shielding of power cables against the high altitude. Because of the high altitude, and the corona discharge, partial discharge can happen at low voltage itself. Actually, in the full electric aircraft, the DC voltage that they're talking about is in kind of thousands of volts. I mean, 1,000 volt, 1,070 volt, and so on. So this 1,000 volt is good enough to create a partial discharge and corona effect at a high altitude. So how we can mitigate these things. And then the concern about the lithium-ion batteries and high C discharge at the onboard when you take off and landing. So these are the kind of the concerns, and still authorities are trying to understand how they can wrap the standards and the regulations and guidelines in order to assist the OEMs and the airframers to design and build the aircraft, and then they can qualify to fly for the commercial purpose. Okay, so this is some of the challenges just to highlight on in the commercializing the full electric aircraft. Okay, so I have 9 minutes. So any questions you have on the topics that I covered today?
Thank you, sir, for your lecture. Dear participant, you can ask.
Sir, good evening.
Good evening.
Actually, my question is, you told about the de-icing of the or exterior of the plane. Okay. So, which type of heater and where it will be placed? You told electric heaters will be used for this, and how to place them?
Okay, so yeah, you can see that here the pneumatic. So this is a pneumatic system. This hot air is used to currently. I mean, which heater is being used? It's kind of I mean, they have a full electric aircraft like Boeing 777 that was the used the more electric technologies, but I'm not very sure or whether, I mean, but that the aircraft is to be retired. Any aircraft using the electric heater now, but I can explain to you that what is being currently, I mean, in the conventional aircraft, how it is being done. So the APU, which is a small auxiliary the generator, I mean, it's a kind of, it's an engine which also coupled to the generator. So this engine just pump the hot air because the engine runs at the high temperature. So this hot air is being pumped to the tail and then the wings, as well as on the windshield. I mean, near the for the windshield of the pilot. So this hot air is basically used to melt the aircraft on the, I mean, ice on deposited on the wings, tails, and then the windshield as well. So this is the wing technology, and then the focus is being given by the industries and the airline to, I mean, airframer to see whether it can be replaced with the heaters. The heater, in sense, is kind of a normal. Using the resistive heating to heat the heat the wings on the tail to melt the ice. So that's the focus here. And also the cabin to heat the, yeah.
Thank you, sir. Thank you for answering the question. Thank you.
Thank you. And also for sometimes, I mean, as I mentioned, for the maintaining the temperature to heating the cabinet, they bleed the air, which is compressed by the gas turbine engine, which is the hot air. We've been bleeded to the cabinet. So this is creating inefficiency in the engine. So again, the heater is being used, air conditioning system, and is basically used to maintain the temperature in the aircraft, like, using the electric air conditioning system. Okay, so any other questions? Let me see, are there any questions in the chat? Okay.
Thank you, sir. I think
Okay. No other question, I guess. Yeah. Okay. Okay. Thank you very much, sir, for your questions and listening. Thank you, sir. Thanks, everyone.
okay. Good
Yeah.
night.
Bye-bye.
Bye. Sir.